SpaceX Falcon 9 out of control is on the collision course with the moon. Did you hear the news? The moon is about to collide with a SpaceX rocket. Surely this is ridiculous. What is occurring there? Amazingly, after hurtling through space for over 7 years, a portion of the rocket is likely to crash. After being launched from Florida in February 2015 as a component of the NOAA's Deep Space Climate Observatory program, it will reach the moon the following month. The rocket's second stage, however, became abandoned after the first stage's lengthy engine burn had finished and the satellite was launched toward the Lagrange point. It meandered for 7 years, taking very odd detours and revolving in extremely unique orbits determined by research on our solar system's chaotic dynamics. And specifically, it can be considered as a small body in the gravitational field of the Moon, Earth, and Sun. As a result of the peculiar behavior of such objects in such systems, the rocket's orbit will soon cross that of the Moon. Because of this, there will be a crash in 7 years. Space experts think the rocket, which weighs approximately 4 tons of space debris, is soon to collide with the moon at a speed of roughly 2.58 kilometers per second. To learn more about it, watch this video with me. According to Bill Gray, whose software tracks comets, asteroids, minor planets, and near-Earth objects, the top stage of the Falcon 9 will very certainly collide with the far side of the moon on March 4th. Perhaps, scientists will take advantage of this impact to better understand the moon's unexplored regions. Receiving an undesired impact for free to investigate the moon's surface is not something that happens every day. But who is Bill Gray? And what exactly do we mean when we claim that the upper stage of a Falcon 9 will strike the moon? Data analyst Bill Gray is a part of the so-called Project Pluto. Project Pluto offers both paid and free astronomy software to both amateur and professional astronomers. The orbit determination program of Project Pluto, named Locate Orb, can take a series of positional measurements of an asteroid, comet, or natural or artificial satellite and determine its orbit. Hence, the main task of Project Pluto and Gray is to calculate orbital parameters. This makes the man one of the most trustworthy sources of information because of how accurate his measurements are. According to Bill Gray, the object flew by the moon more closely on January 5th, but it will definitely have an impact on March 4th. This will be the first inadvertent case of space trash reaching the moon of which we are aware. Let's go on to the Falcon 9. Let's examine its construction. The Falcon 9 rocket has the following appearance. It has several stages, as you can see from the image, and the one on the left is referred to as the initial stage. First stage. When we state that the Falcon 9 is a reusable rocket, we imply that the primary stage can be recovered, brought back to Earth, and then readied for another launch. Reusability enables SpaceX to relaunch the rocket's most expensive components, lowering the cost of space access. 9 Merlin engines and aluminum lithium alloy tanks storing liquid oxygen and rocket-grade kerosene propellant are included in the first stage of the Falcon 9. At sea level, the Falcon 9 produces more than 1.7 million pounds of force. Second stage. The second stage, propelled by a single Merlin vacuum engine, transports Falcon 9's payload to the appropriate orbit. A few seconds after stage separation, the second stage engine fires, and it can be restarted numerous times to deliver various payloads to various orbits. Interstage. The interstage is a composite structure that joins the first and second stages and houses the pneumatic pushers that allow the first and second stages to separate during flight. At the base of the interstage, for hypersonic grid fins are a feature of Falcon 9. By shifting the center of pressure, they may rotate the rocket during re-entry. Payload. The payload is the following. The fairing, which is made of carbon composite material, shields satellites as they go toward orbit. About 3 minutes into the flight, the fairing is discarded, and SpaceX continues to recover fairings for future missions. The second space's cylindrical shape makes it more difficult for Falcon 9 to calculate its orbit than it initially appears. In fact, findings can vary by orders of magnitude, and it is typically harder to estimate the orbit of a spherical object than a cylindrical one. The precise location of the rocket's impact is therefore unknown. The sun-related uncertainty is one of our primary concerns. The rocket is being pushed by the sun through its radiation pressure, and this causes uncertainty in our measurements of spin times, which could slightly change the rocket's orbit. These effects, even if they are very slight, will add up between now and March 4th. This means that in order to pinpoint the particular time and place of the impact, we will need to make further observations. You might discover that this animation depicting the object's motion in 2022 helps you understand what's happening. This depicts the path as seen from a bit above and to the side of the Earth-Moon system. The moon is on the white track in the animation, which mainly repeats itself in a neat, regular ellipse with slight variations brought on by the sun's gentle pull. The course of the item between January 1st and its collision on March 4th is seen below. Will Earth be able to see this collision? Well, it will take place on the moon's dark side, also known as the far side. The moon's size is in the way, and even if it were on the near side, the impact happens a few days after new moon, making it extremely difficult to detect. Space aficionados think the impact could yield useful information. You must believe that this news is great. The astounding thing, though, is that this isn't the first time anything has crashed on our moon. Some of our spacecraft were purposely crashed into the moon by humans. For instance, NASA intentionally destroyed the rocket booster stages, the SIVBS, on several Apollo flights in order to gather scientific data. It allowed them to take seismic data to help them characterize the lunar interior. Because they remove space junk, deliberate collisions with the moon or other planets in our solar system are also advantageous. You may observe that a significant number of the artificial things on this list were deliberately crashed if you look through it. Yet the one gained with the L.C. Ross mission is among the most significant examples of deliberate crashes. L.C. Ross was created to gather and transmit information from the impact and debris cloud caused by the launch vehicles used Centaur upper stage striking the crater Cabeus close to the moon's south pole. At an impact velocity of roughly 9,000 kilometers per hour or 5,600 miles per hour and a nominal impact mass of 2,305 kilograms or 5,081 pounds, Centaur produced the kinetic energy equivalent to detonating about 2 tons of TNT. On October 9, 2009, Centaur successfully impacted. Experts anticipated that the impact's expelled plume would have contained some traces of water. As it passed through Centaur's expelled plume, the shepherding spacecraft recorded and transmitted data. The impact and its associated dust cloud could not be seen from Earth with the unaided eye or with telescopes, in contrast to what the media had reported at the time. NASA was dubious about the existence of water because of this, but in the end, they were able to detect traces of it in the data from spectrographic measurements, which measure light absorbed at different wavelengths and reveal different compounds of the Centaur stage crater and the two-part debris plume the impact created. Both infrared and ultraviolet spectroscopic studies revealed the presence of water. Remarkably, scientists observed signs of the water in both an infrared and an ultraviolet equipment. And it is because of this that we are currently so confident in our findings. What can we infer about this effect? Make sure to like or dislike the video before learning the answer to this query so that we can keep improving and making these films better for you, the viewer. Gray believes that we won't see the effect. On his blog, he states, "I know a fair amount about computing orbits, but I'm no more knowledgeable than the next guy about which satellites orbiting the moon can do what. I am aware that Chandrayaan-2 and the Lunar Reconnaissance Orbiter, LRO, are in low orbits and that the chances of them passing directly overhead at the appropriate moment are quite slim. So, I don't anticipate them to notice the true effect. But if we can pinpoint the location of the crater for the LRO and Chandrayaan team, they will ultimately travel over that area and be able to witness a very recent impact crater and likely gain some insight into the geology, or perhaps it's better to call it selenology, of that region of the moon. Given that we know the mass of an empty Falcon 9 booster and that it will impact at a speed of 2.58 kilometers per second, we may calibrate the crater size versus energy function using the object's known momentum and energy. This implies that actual science could be conducted, beginning with an unwelcome collisional event. What a time to be alive! Here's where the video ends. Thank you everybody for watching. What do you make of this bizarre crash incident? Do you believe we will watch it? Please share your thoughts in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.